In this video, we're going to have a look at the applications of trigonometry and the solving of triangles. We're going to start off having a look at two new definitions before we start with the applications. Firstly, we're going to have a look at an angle of elevation. This is an angle that is measured from the horizontal line upwards. An example would be you looking up towards the top of a building. Next, we have an angle of depression. This is also measured from the horizontal line, but is measured downwards. For example, if you stand on a cliff and look down towards the sea. Example 1. A man stands 800 meters from the point where a hot air balloon took off and looks up at the hot air balloon at an elevation angle of 78 degrees. Calculate the height of the balloon from the ground. Because in trigonometry we work with right-angled triangles, we are going to accept that this hot air balloon moved directly upwards. That means we can form a 90-degree angle between the ground and the movement of the balloon. As your trigonometry progresses, you will also be able to work in other triangles. Now we need to add all the information on our sketch. They say that the man is standing 800 meters from the point where the balloon took off, so that is 800 meters horizontally on the ground from the point where the balloon took off. Next, we are told that the angle of elevation is 78 degrees. Remember, that angle is measured from the horizontal upwards, and this angle is given as 78 degrees. We are asked to determine the height of the balloon from the ground. Now that we've added all the information on our sketch, we can use the usual steps to solve triangles. Firstly, we need to decide which angle will be our reference angle, and that will of course be the angle where the man is standing. From here, we now need to name all our sides. We need to determine the opposite side, and we were given the adjacent side. This means we can work with the tan ratio from our reference angle of 78 degrees. The tan ratio is the opposite, which in our case is the height, and the adjacent, which was given as 800 meters. To solve the height, we now need to multiply with that 800 on the left-hand side. Using your calculator, you will find that this balloon is 3,763.7 meters from the ground. Example 2. Calculate the height of a cliff if the angle of depression from the top of the cliff to a boat at sea is 42 degrees and the boat is 700 meters from the foot of the cliff. The boat is in the same horizontal plane as the foot of the cliff. Again, we will start by adding all the information on our sketch. In this case, we are asked to determine the height of this cliff. The first part of information given is that the angle of depression. Remember, that angle is measured from the horizontal downwards, and this angle is given as 42 degrees. The boat is 700 meters from the foot of the cliff. And here it is important that they mention it is in the same horizontal plane as the foot of the cliff. Because it's in the same horizontal plane as the foot of the cliff, we can accept that it forms a 90-degree angle towards the top of that cliff. Now we have a right-angled triangle, and our next step is to determine which angle in the triangle will be our reference angle. The angle of depression that was given is not inside the triangle, but because we are working with horizontal and vertical lines, we can accept that the horizontal line at the top of the cliff and the horizontal line at the foot of the cliff are parallel. This is why we can say that using alternating angles, the angle of elevation towards the top of the cliff from the boat will also be 42 degrees. This angle of 42 degrees forms our reference angle, and that means the height that we want to calculate will be the opposite side, and we were once again given the adjacent side. This means that again we'll be working with the tan ratio, and this time from a 42-degree angle. The opposite side is the height of the cliff that we want to calculate, and the adjacent side was given as 700. To solve h, we are again going to multiply on the left-hand side, and this will give you a height of 630.28 meters. Here you've now seen that when it comes to applications of trigonometry, you start off by adding the information on your triangle sketch, and then you follow the usual steps for solving triangles.